So this question basically is I've got a function. The function is this bracket times this bracket. I want to find all solution of fx equal to 0. The first one is pretty straightforward, nothing to do with this chapter. Fx is y, on the left-hand side, I just want to make y equals 0. So part A, I'm going to put solutions here. All I have to do is, so first question is basically pretty much year 10 5.3. It's nothing to do with this chapter, but we need that scaffolding to build. Okay? So here, we recognize this bracket is the difference of two squares. Yeah? So that is a plus b, a minus b. So a plus b, a minus b equal to 0. Therefore, I got x1 equals minus 3, x2 equals 3. It's pretty much a. Yeah? Now b, find the coordinates of turning points. As soon as I'm reading that phrase, I'm thinking about first derivative and stationary points and all that. The graph y equals fx, determine the nature. Now, by now we've done second derivative. So for this question, I'm going to use the second derivative to determine the nature of this maximum, minimum, point for inflection, etc. I'm not going to use the table approach, which we tried a few days ago. Okay, so let's have a look. Now, many of you have done product rule, yeah? But because it's one bracket times another bracket, I'm just going to expand brackets. So f of x equals, I'm just going to do that. Yeah? So it's x cubed minus 9x plus 3x squared minus 27. You guys okay with that?
Yep.
I'm going to write down x cubed plus 3x squared minus 9x minus 27. So that's f of x. Then f dash x. Adrian, what's f dash x?
3x squared plus 6x minus 9.
Excellent. 3x squared plus 6x minus 9. We know at stationary points, f dash x equals 0. So last, the day before yesterday, I've said we equal to 0, but we try not to write like that. All right? So we try to add an extra line. We say at stationary points, f dash x equal to 0. Therefore, that equal to 0. That is more meaningful than just write here equal to 0. Because in HEC, they might say this is not quite reasonable reasoning here. Okay. From here, once again, year 10 5.3, factorize from here. Okay. Then common factor, take it out, you get that. Through brackets, x minus 1, x plus 3 equal to 0. Therefore, we've obtained, what do we get, Mitchell? X equals
1 and
yep, x equals 1 and x2 equals
-5.
-3.
thanks. All right, then we said we want to find the coordinates. Yeah, so in an exam, make sure you don't stop here. If they ask for x value, then yeah, we stop. But majority of the time, the question asks for coordinates. What does coordinates mean?
Slot back into the original.
Coordinates means x, comma, y, yeah? Now we found x now, we need to find the y value. So, then we say when x is 1, start back to find the y value. Yeah, we start back to the original function to find the y value. Now from here, pretty straightforward. 1 plus 3, 4. 1 minus 9. What is it? -8, yeah? So it's going to be -32. Is that okay? -32. Therefore, now I can write my coordinate is 1, -32. At the moment, I'm just writing down coordinate. I don't know it's maximum or minimum or not, but we'll find out in a minute. Then we go when x equals -3. Y is -3 plus 3, 0.
0.
Easy. 0 times anything is 0. I don't have to do more calculation. Yeah? So what's the coordinate? -3. 0. Now I find my coordinates. Then I'm in a position to check. Whether it's maximum or minimum. How do I do that? As I said, I'm not going to do the table approach. That takes too much time in the exam. Just go directly to second derivative. What's my first derivative? Here. Yeah? So I'm going to do second derivative now. F double dash x is 6x plus 6, directly from here. Then we go, when x equals 1, check the sign. When x equals minus 3, check the sign. Conclusion done. All right? So, when x equals 1, f double dash x is what?
12.
Good. 6 times 1 plus 6. Again, not interested in the actual value. What I'm interested in is it greater or is it smaller than 0? Yeah?
Does it make a difference if you use the simplified version?
Which one is simplified version?
X squared plus 2x minus 3.
X squared plus, here, from here?
Yeah. Can't use that?
I think you can use that too.
You can use that too?
You can use that too, yeah. Because the 3 doesn't really make a difference.
Yep.
Yeah. Now, yeah.
Mm-hmm.
Now here, greater than 0, therefore it's concave up. Therefore, which point do I have? Which point?
Minimum.
A minimum point. Yeah. Therefore, minimum point. Therefore, you can see, you can conclusion here. Minimum point. Yeah. Then you go when x equals negative 3. That's negative 18. Negative 18 plus 6, negative 12. Therefore, f double dash x is smaller than 0. It's concave down. Therefore, you have a maximum point. Therefore, this one is a maximum point. Now we finish B. B in the HSC is usually 3 marks. 3 marks for all of that. Okay? Let's move on. C. Now we've done A, we've done B. C says, C says, sketch the graph y equals s of x, showing the turning points. Now, from A, we recognize 1x, another x, another x. What function is that? What function is that? We got 1x, another x. Huh?
Polynomial.
Yes, yeah, but it's a, what sort of function? How many x do I have?
3.
So we call that
Cubic.
function, right?
Yeah.
Yes?
Yeah.
Okay. So, but here we can see from these two, we got that. Yeah? So from this, we can tell our x-intercept, which is our zeros, occurred at -3 and 3. You follow? But at -3 is double roots, I'm gonna repeat it. Therefore, you know at -3, the cubic function gonna bounce back at -3. And the leading coefficient is positive, positive, positive. So I know I'm gonna go this way rather than going this way. Okay? That's sketching cubic function. Again, previous knowledge. So we're gonna use that knowledge to do C, and plus this to finish C. Now, I'm going to write down here now, sketch the graph. So sketch the graph, I got x-intercept is 1, 2, 3, 1, 2, 3, so 3 minus 3, x-intercept down. Y-intercept is when x equals 0, 0 plus 3 is 3, 0 minus 9 is minus 9, 3 times minus 9, minus 27, so it's gonna be there. Okay? Now, from left to right, we're not gonna go this way. Therefore, and we know at -3 gonna bounce back. So we know it's gonna be that's it. Now the question, even in a few weeks' time in our assessment task, the question will also say sketch the graph, clearly label x-intercepts, y-intercepts, etc., etc. Therefore, we're gonna label that. So this point is what?
-3 and 0.
-3, 0. This point is 3, 0. This point is 0 and negative 27. Yeah, last one, then we're done. For what values of x, I'm going to write down here now, part D. Sorry about that, it's a bit messy. For what values of x is the graph concave down? Now the question says concave down now. Where as soon as you see that word, you think about concavity, you think about second derivative. Yep.
So isn't the minimum point 1, negative 32?
Which one are you talking? Part C or
Yeah, just below D,
just below D?
just below question.
Oh yeah,
D,
yeah.
You have
Yep.
minimum point as 1, negative 32.
Yep.
But on the graph it's 0.
No, but I didn't draw it yet. This is just quick sketch.
Oh, that's the
Yeah.
x.
I just
That's the
quick
y-intercept, not the minimum point. He drew it wrong.
All right.
Do you get?
So
the minimum point would
I
actually
should
be shifted
I should
over.
move right a little bit more. Yeah, but quick sketch. Okay. Found what values of x is the graph concave down. So whenever a question talk about concave down, I'm thinking about second derivative is what? I'm thinking about
Negative.
second derivative is
Less than 0.
smaller than 0. Very good. So what's the second derivative here? So you think about second derivative is smaller than 0. That's inequality is quite straightforward, right? So it's just gonna be x is smaller than -1. Now, having done that, x is smaller than -1. Where's -1? Here. Yeah? X is smaller than -1. So just double check with your graph. When x is smaller than -1, the graph is concave down. After passing x equals -1, the graph is concave up. Therefore, there is a change in concavity. Yeah?
Mhm.
That's it.